Hi, welcome back, and this is the third of my being very sick videos. 5.3 Investigating Sine Function. So what does this sine function look like? Well, I had a pretty good idea it's going to look like this, but let's figure out why. So first thing you're going to do is from the website, you're going to have this handout, and all you're going to do is just actually plug things in. So if I have sine of 0, you plug it into your calculator, and that gives you, well, sine of 0 is actually 0. And then you plot it here. Sine of 0 is equal to 0. And then you go sine of 15. I don't know what sine of 15 is, so let me just go to the calculator and clear this. Sine of 15 is equal to 0.26. Switch 0.26, and sine of 15, that's 30, so 15.26 would be somewhere around there, and etc. Plug them in, put them on the calculator, and then put all the points and see what that looks like. Once you actually filled in and have the shape, then answer this question: what is the amplitude, what's the period, what are the x-intercepts, what is the domain and the range. Please have this information, because I'm very likely to ask you this on quizzes and tests. So figure it out, and if you need to, look at the PDF for the actual answers. Okay, so the unit circle and the sine function. Now you should have done this before you look at this part. Okay, so stop. I will provide you with this handle online just in case, but stop the video and then don't watch this part. 3, 2, 1. So here's an animation that I found. How does this work? Well, sine of an angle is the opposite over the hypotenuse. If we are using the unit circle, the hypotenuse is always going to be 1. So basically it's the opposite over 1. So it's just the opposite. And the opposite is always going to be y. In other words, the sine of an angle is going to be just the height of the unit circle. And that's why the unit circle is so convenient for us, because we can just measure and figure out what sine of the angle is. So if the animation starts at sine 0, sine 0 is 0 because the opposite right here is just 0. The height of this point is 0. If I go a little bit, well, as I go, okay, so this is messing us up a little bit. The angle here is measured in radians, I believe. So forget about this part, but sine of this angle means it's this height. But when I get to the top, well, the biggest sine I'm going to have is sine of 90, because it's going to be the highest point. After I go more than 90, it starts coming down. So when it goes to 90, it's at the top, and then it starts coming down. And what's going to happen when it gets to, well, sine of 180? Well, the height's going to go back to 0. So at 0 is 0. At 90 is 1. At 180 is 0 again. And now remember that this is 270, right? So now something strange happens. I'm going to get negative numbers for sine. And try it on your calculator. Any number above 180, like sine of 200, you already got it. That is a negative number. Why? Because the height now goes below the x-axis. And at 270, it reaches the lowest point, which is minus 1. And then at 360, I'll stop it right before. At 360, it will be again go back to 0. Does that make sense? So on our next slide, here we have everything that we just saw. So this little circle represents this point, right? Sine of 0 is opposite over hypotenuse. Hypotenuse is always going to be 1 because it's the unit circle. Therefore, it's just the height, and at 0. At 90, well, it's the highest point, and that's a 1. I go 180, then it goes back to 0. And as I go all the way to 270, that's the lowest point, and that's the minus 1. And then when it fills up the whole circle, 360, it's where we started. And then, of course, going to go on. Now, if I do a negative angle, well, that's going to go with the shape going this way, because you know that the shape goes on forever and ever. Does that make sense? So I think I asked you to do this on the excuse me, on the first page, but then repeat it here if you can. What is the amplitude? What is the period? What are the x-intercepts, the y-intercepts, the domain, and the range? I know this is getting cut off from your video. See if I can move it. Oh yeah, I can. And then fill that in, and that information will be available on the PDF for the answers. But that's important for you guys to know. Well, let's do some of them. The amplitude. Well, the amplitude is from the middle. Let's do the axis of symmetry first. I like to do that on red. The axis of symmetry is right through the middle, and that's y equals 0. I didn't say axis of symmetry here. So axis of symmetry is y equals 0. Then the amplitude, it's from the middle to the top, or the bottom, and that's equal to 1. Right? Because from the bottom, middle to the bottom, middle to the top, that's always 1. I forgot to mark the top, the max, and the min. The amplitude is from the middle to the top, or the middle to the bottom, and it's 1. The period, well, I gotta mark one shape. Let's say that we say that the shape starts there. So the period is from here, from 0. I can't switch. There. From 0 to 360. That makes perfect sense, because as it rotates one full turn, the whole pattern will repeat itself. The x-intercepts, well, that's going to cross at 0. Let me switch colors. Going to cross at 0, at 180, at 360, at negative 180, at negative 360. So I go like, I'm going to have a whole bunch of them, right? Negative 360, 180, negative, at 0, 180, 360, etc., etc. I'm going to have infinite times that this thing crosses because it goes on and on. Y-intercepts, though, there's only 1, and it crosses right there at 0. The domain, well, it goes on forever from left to right, so that's easy. X belongs to the real numbers. And the range, well, it's y belongs to the real numbers, such that what's in between 1 and minus 1, right? So minus 1, y, and 1. Should put my set notation. And there it is. So I'm just giving you only 5 questions to practice. It's going to be a little bit repetitive and fairly simple, but it's based on, it's good practice for what we're going to do next, because we're going to start modeling and modifying the crap out of this one. So making bigger amplitudes and shifting it over and over. So you got to know the basics very, very well so we can modify it. Well, I will be seeing you soon.